Well, hello there. Welcome back to my channel. And in this video, we are gonna learn about, or we are gonna walk through the very basic concepts and get a very brief understanding of the Intel's distribution of OpenVINO toolkit. And in the second part, we are gonna see a very quick demo of how we can implement object recognition using OpenVINO in a platform called IoT Dev Cloud provided by Intel. So let's begin. So what exactly is OpenVINO? It's a toolkit for high performance deep learning inference. Concentrate on the word inference. It is just a tool for inference. It is not a tool for machine learning training. It is a tool for inferencing the input and to get the output. And this is what it explains here. Traditional inference that are present with us, like within TensorFlow we have, like there are various traditional inference tools that are available with us, and then there is OpenVINO, and that's where I tend to deviate to, and that's what it has been shown in this picture. So what exactly it consists of? It consists of a deep learning inference engine. So it consists of basically an IR engine in which you provide the input, you get the output. It consists of a traditional computer vision libraries, which includes OpenCV and OpenCL, which we are all familiar with. And the most important part, it includes the hardware acceleration capability. So basically, OpenVINO is just a bundle of several tools optimized for Intel platform. Which are these tools? These include inferencing tools for deep learning neural nets. We have tools for computer vision, which includes Intel optimized OpenCV and Intel optimized Python. And then finally, we have the hardware acceleration on Intel architecture that is implemented by the IR engine using OpenVINO. So why do we need it? To understand why do we need OpenVINO, we need to understand how this entire thing works. As in, if we are deploying a computer vision application, what are the two phases for it? The first phase is the training phase, in which we have a data set and we send it to we basically we take the data set, we train the model, we create a model, probably we train it on a GPU, and then we get the final output either as weights or biases or like something like a trained network. For TensorFlow, it might be a frozen inference graph. So that's the training phase. We are not concentrating in this area. It is assumed that when you're working with OpenVINO, you have a trained model with you using any of the frameworks that is available. What is interesting and what OpenVINO targets is a second layer, which is the inference phase. What happens here is like you have input, you pass it through the trained model, and it gives you the output. So here OpenVINO does the real magic. How it does, we'll see it in a bit. Before we understand like why OpenVINO is so much useful to us, let us understand what exactly it consists of and why it is used. So if you think of a scenario of practical computer vision, we need to understand certain factors that are there. When you're deploying a practical computer vision application, it is not always possible to do the processing at the cloud level, and also it is not always possible to do the processing on high-end computational nodes. For that reason, we might want to stick with some nodes that are not computationally intensive. But what will happen if we try to run a piece of code, or we try to do inference on a non-computationally powerful node? It will fail. It will give very low FPS. The result won't be accurate, right? And that's where OpenVINO comes into the picture, and it performs that optimization for us. So it's all about processing at the edge level, or what we commonly call it as AI on edge. We have the edge nodes, which may consist of a CPU, it may consist of a NCS, it may consist of FPGA, it may consist of anything. We'll see that very soon. And we do all the processing, all the inference at the edge level. We don't do anything at the cloud level. So you have an input, you get a trained model, you pass it through that, you get the output. That's the inference phase, and that's what we do when you develop some practical computer vision application, mainly involving video or image processing. So for the steps, in terms of OpenVINO, what we have is like we have a trained model, as I said earlier. We pass it through a model optimizer. Now, this model optimizer creates two files. One is a XML file, the second is a bin file. This is known as the intermediate representation layer or the IR layer. The IR consists of two files, and then these two files acts as the black box and acts as a core component for the inference engine. And then what happens is our user application, the main application which we want to develop, finally it interacts only with the inference engine, and the inference engine feeds on the XML and bin file for the data that is required. So what essentially is happening out here is that you have the user application, it interacts with the IR engine, and that's it. That's what OpenVINO targets. OpenVINO consists of a model optimizer and an inference engine and a list of many tools. Model optimizer optimizes a model such that it can be run on the OpenVINO environment. What IR does is uses that particular model or trained model, that is the XML bin file, and does the job for you. Well, some of the key pointers that is relevant when we are speaking on OpenVINO, and the most important pointer I will mention, that is write once, run anywhere. You write a single piece of code and you can deploy it to any edge node. Now this edge node includes CPU, GPU, which has to be on an Intel architecture. We have Myriad X VPU or a visual processing unit or FPGA. Now what is a VPU? It's basically it's a hardware device that is specifically made for inferencing computer vision applications. It is used rapidly, like it is used almost in many places. Like for example, let me just give you a slight deviation. This is something that I have faced with me while I was working on any project. We have a Raspberry Pi, and in Raspberry Pi, when I deployed OpenVINO, I remember getting like something similar to like 8 to 9 FPS. And when I deployed the same thing with an NCS attached, NCS is the Myriad X CPU by the way, with the NCS attached, then my FPS increased to something like 15 or 20, which is pretty much good when it comes to Raspberry Pi. People who has worked with Raspberry Pi will understand this very easily. We don't, we really don't have the luxury in a single Raspberry Pi to work on to get higher FPS, but with NCS and OpenVINO it's possible. So the major point out here to note is that you write a single piece of code, you just need to modify the parameter that where you want to deploy. That's it, you deploy it anywhere. We'll see all the deployment methods and how the performance affects in the demo, but as of now just understand the fact that we write a single piece of code, and in fact you will see in the demo as well, we have written only a single piece of code, and then we deploy to every possible edge node that is available in the Intel IoT Dev Cloud. So just let me just recap you over the entire concept of OpenVINO, and then we can move to Dev Cloud platform for demo. It's an inference tool. So it consists of a inference engine, which is a main component. It consists of the openly available open sourced computer vision libraries, and finally it contains the hardware acceleration, which is one of the major pointers to look into OpenVINO. That's it. It's very simple. There are lots of examples that are available over the internet. The link for basically downloading OpenVINO is mentioned somewhere in the description. You can download OpenVINO and try to explore as much as possible. It is supported in Windows, Mac, as well as Linux, and you can obviously like raise a request for getting Intel Dev Cloud access, and with the project idea, and probably it will be accepted, and then you can work on Dev Cloud. So let's head to the Dev Cloud now and do some real cool demos. Well, hello there. Thank you for watching this video. In this video, I covered some of the basic concepts related to OpenVINO. In the next video, what I will try is to cover some of the key areas related to DevCloud and what are the nodes available and how the inferencing at edge actually happens and how you can use it to evaluate your model, as in how it will really inference on when you're deploying it on a physical device. I intended to do this video as a single video, but then I realized that it was getting too long, so I decided to break it into two parts. The first part was dedicated to some of the basic concepts of OpenVINO, while the second part will be dedicated to the Intel IoT Dev Cloud. So thank you again. If you like this video, please hit the like button, share and subscribe to my channel, and we'll meet you soon. Until then, stay safe and stay at your home. Have a good day. Bye.